This problem is a two-part problem. It's about a hawk that's flying in an arc. So I'll draw a picture. It'll be a top-down view. Put the hawk right here. It's got some speed. It's traveling in some radius. And it's asking what is our centripetal acceleration. In my particular problem, I know that the radius is 10.3 meters and the speed is 4.8 meters per second. Oh, 10.3. So looking through my list of equations, the one that has centripetal acceleration and has velocity and radius would be v squared over r. So that would be 4.8 meters per second squared over 10.3 meters. 4.8 squared divided by 10.3. 2.2369 meters per second squared. That's not that difficult. If you've been going through the homework, that's probably going to seem kind of simple. The next question, though, might throw you if you haven't seen it before. So we have this hawk flying, but it's no longer a constant speed. At this particular moment in time, the hawk is accelerating. The hawk speeds up. So I'm going to put an acceleration vector here. The acceleration of the hawk is 0.63 meters per second squared. Now we still have the centripetal acceleration to go in this particular circle. The centripetal acceleration points towards the center of the circle. And that's our 2.2369 meters per second squared. So if I do a acceleration diagram, and hopefully you see where this is going. We have two accelerations that are at right angles to each other. So I'm going to add them together like vectors, or as vectors, because they are vectors. And so the total acceleration of the hawk would be the hypotenuse. I'll just say total. So that's going to be equal to the square root of 0.63 meters per second squared plus 2.2369 meters per second squared. And I get 2.3239 meters per second